and it's taking photos. It can only take a photo that's so large at a time. So you need to use.
Okay, we're going to get into satellites, and I can't even start with your topic there. What temperature does aluminum melt at?
I have no idea.
Okay, if you get into space, it won't last. I'm electronics.
Let me share my perspective rather than.
I've been 36 years in this business. I worked for a television studio for 8 years. I know all about satellites. I've worked with it. I programmed them. Dude, there's no way a satellite could be in space and not melt.
I'm saying to understand the other perspective. That's my whole point.
Well, we did first.
Yes. Well, I'm not sure if you fully have.
But we did.
Yeah, we all did.
That's
until about 3 or 4 years ago.
You don't believe that we understood the perspective, but that was the first thing that we all had the job. That was my job. I understood exactly what I was told. There's a satellite. I have to find the satellite dish too. That was my job. I had to find that satellite dish.
It's the size of a nickel. Supposedly we have to point.
You get close and you watch the ohm meter and you perfect it and you get the angles just right. That doesn't mean there's something there. That just means that what I pointed to was able to hit something, whether it was
reflection.
A reflection?
I think it was a reflection.
I don't know.
Natural occurring.
But I can theorize now that it was a reflection.
Well, what do you say about the $1 trillion space industry? Is it all a scam?
It's a money grab law.
$50 million a day is that.
You have aerospace engineers who launch rockets, they launch
satellites.
They never go out of space. They go in an angle.
Yeah, I disagree with that. So would the aerospace engineers.
The launches go up and they curve.
Oh, come on now, Elon Musk, he re-landed his, you know.
Come on now, man, that just did it for me too.
It must be real.
Right. You haven't seen these things into outer space, turned them around, flipped them around, what, a second and a half?
Yeah, they could
75,000 miles an hour, and floated it backwards and landed on its back.
It's a thing of absolute beauty and a marvel of human achievement.
Wow.
Hold on, the Orion,
Yeah.
The re-entry video on the Orion, sorry.
It tells me, everything I've seen tells me it was a big old video that was made for our enjoyment.
Yeah.
And propaganda.
I wanted to see the Orion video.
Talk about that much money.
Channel.
And there's no way that I can contest that, because that's how you feel.
We can't go.
They make really good films.
You want us to
one at a
prove
time.
our point.
Everything.
But the question is, you're taking them for their word. You are taking a known liar for their word.
Well, this is where I was saying understanding the other perspective fully. You know,
Well, what if we do? What if we did understand?
and if it makes sense.
No,
what doesn't make sense?
It did make sense up until a couple of years ago.
Yeah.
But what does not make sense in their arguments? If you can find those points that do not make sense.
Let me give you an example. Let me give an example.
Please.
Okay. Here, you had this up the other day, or a few minutes ago. This is the moon. Okay, watch that. Okay, I did this. Okay, get online and do a search and pull moon's gravity affects the tides. Okay, and
But not in a lake.
I opened it up, 50 pages, every hit, and read all of them. Okay, because here's the problem. Here's the moon. Now, science will tell you that 9,000 miles away from the moon is null gravity, zero gravity. You can park a pink Cadillac there, you can park the Houston Astrodome there. It will not be sucked, gravity will not bring it to the moon, it will not bring it to the earth. That's simple science. There's a zero gravity place there. Moon's gravity affects tides, okay? Do you know that when it's high tide on both sides of the earth?
I was going to say,
Simple
there's two high
fact.
tides a day, right? There's a high tide in the day and a high tide at night, right?
Yeah, twice a day. And now some places it's 40 feet difference and some places it's 1 foot. But that's irrelevant to this. Okay, the moon's gravity affects the tides. Now I opened up every one of those. And it was high school professors, there were college professors, there were physics, you know, I read them all. There were some really stupid things, you know. But when asked the question, why does the moon's gravity make it high tide on both sides of the earth? Well, the moon's gravity pulls the water away from the earth on this side. What about the other side? The moon's gravity pulls, I shit you not, the moon's gravity pulls the Earth away from the water. Now, I did that deliberately, and then I punched in magnetism, electromagnetism, moon, and tides. Oh, in 1859, scientists stretched a cable across the Thames River in London and measured the voltage at low tide and high tide, and there was 32 volts or whatever it was difference. They knew this back in 1859. So there's a whole lot of stuff that's been swept under the rug, a lot of, you know, obfuscation, a lot of, you know, just hiding the facts, burying things, and killing a lot of people to bring us to where we're at right now, including Tesla.
I think that's the answer to your collapsing bubble light also. I was gonna say, water holds, like you could take a voltmeter and put it in water and get a voltage, right?
Yep.
Right, from, but there's gotta be a source though.
It's, the water's electric. It's
Well, magnetism. All magnetism is electrical, and all electricity is, or you know, all magnetism is electrical.
Every atom.
Let's keep it simple again though. If the moon had gravity that was affecting the tides, how come big bodies of water don't have the same effect?
Gonna put it together outside or in
It
the
shouldn't.
ocean?
If it's pulling on the ocean over here, why isn't it pulling on this big lake? There's no water running in and out.
Lake Baikal, Russia, it's perfectly flat.
Maybe because
And when it's frozen solid all winter long, it's perfectly flat.
Like it's, I'm kind of on the fence about it. I'm more over on the flatter side. So, like, I think it's the way science explains it. The larger the object, or the larger, or the more the density.
Yeah.
So, like, maybe it would have more of an effect on the ocean than it would a lake.
Why should
If
compass
I may answer
not point to the middle of the earth if that's magnetic?
But a gallon of water is a gallon of water still.
I got a
Unless
question
it's
for
got
you
salt.
guys.
Yeah.
Has any of you been to the
to that
southern
point, when you're
hemisphere?
talking about a lake,
You
it's
do
a
that.
set quantity of
Does
water.
a compass
You know,
point
there's
south?
a million gallons
You know, I
of
didn't.
water in that lake.
You know, I did
That's
use the compass
not
a
gonna-
lot
that's not
there.
gonna-
Does it point south?
I
Because
don't
the
remember.
northern hemisphere, I know for sure because I live here. I've used a compass. It points north.
North, but not to the center of the earth where
That's my thought of how
it's,
they
it's molten lava, and everybody knows you get your magnetism whenever you melt something and it's liquid, you lose
You
all
lose
your
your magnetism.
you lose your magnetism. So I don't buy it at all. And we've only been able to go 8 miles
Yes.
into the earth. So how
That's
do we?
what
Literally,
we know.
physically verified, drilled 8 miles deepest ever.
Yep.
Yeah, the center is just theorized as to what.
Theorize, theorize.
Everything
theorize.
past 8 miles is a theory.
Section in the book, in the science book.
But that always got me though. If the gravity from the moon is causing all this, but it's in neutral space, the gravity doesn't have an effect. But somehow it has effect on the water.
Yeah.
But not on all water. Just, well, that's the salinity of the ocean, or that's the more water, so it does stuff.
Yeah, in other words, takes of Lake Baikal should have.
I think I have an explanation
Okay.
for that. If the lake is a set quantity of water, let's say 1 million gallons of water, that's not going to change. It can't pull that or draw that water in from anywhere else. But on the ocean, where all of that water is connected,
Being drained
so
out.
But it's still a set
If I
amount.
may, Great Lakes.
Well, let me explain my
Great
point.
Lakes big.
Let me finish my point before interrupting.
Yeah.
So if you have a gravitational pull over here and it's attracting more water over that way, then it could pull that water. Now, I have not heard that the tides are high on both sides. That would probably counter that point. But you know, if I would imagine that if there's a gravitational pull over here, it could attract more water in a way differently than it would affect lakes.
I got another question for you. This'll really get you. If we're spinning 1,000 miles an hour at the equator, why doesn't all the water be pulled to the center equator? Why would there even be land in the center equator? All that water would go to the middle. Take the tennis ball, put the water on the tennis ball, spin it. The water goes to the center and flings off.
I'll answer your question when you give me a chance.
Gravity.
1,000 miles an hour sounds very, very fast, but relative to the large scale of Earth, I don't think that it's that fast.
Times
Miles per
64,000
hour.
miles an hour.
Miles
around the
per
Earth.
hour.
Yeah.
Miles per hour.
Yes, but
scale,
relative.
scale.
But it's still
I think
miles,
he's
it's still
trying-
relative to the scale of it.
Centrifugal
Have you
force.
been through
Wouldn't it build up a little bit?
The force.
Wouldn't the water a little bit be more
Hold on.
higher in the
You ever
middle?
ridden in a
Okay.
Let me say something.
Let me say like you're going slower.
Neil
than you
deGrasse
actually
Tyson
are?
says what? Because the Earth is spinning, it's fatter at the equator, correct?
That's what he just
The
said.
land is affected. It's so fast that the land is stretched out of shape, and it's fatter at the equator.
Right.
Well, I think
Water
that-
doesn't. It affects the land, but it doesn't affect the water.
Yeah.
Yeah.
Okay. So if this globe were spinning at 1,000 miles an hour, it would be ridiculous, right?
Yeah.
Right? It would be flying like crazy.
Well, prospectively, that would be spinning maybe 2 or 3 miles an hour.
Yeah. Okay. So this is going like crazy. Okay.
Mechanics
now,
mean
if
but
we,
rim
if we double the
velocity.
size of this, and I give that the same amount of power here, is that going to be going quite as fast? Not quite. Relatively, it will be going a little bit slower. If we expand that larger, 1,000 miles an hour doesn't seem all that fast if you're talking about a massive.
What about the 64,000 miles around the sun that we're spinning like this, and we're also spinning around the sun?
Get it right.
As the sun is moving,
66,666,000.
And then we're actually
Yeah, I'd love to finish it.
going through the universe at
I see what you're
even.
saying, though.
Okay.
One third,
So it would be
one thing
spinning
at a
1,000
time.
miles an hour. Just
Yeah,
like that.
1,000 miles an hour is only looking, something like
It's
one
still 700 to
revolution.
800 miles an hour in North America.
One revolution per 24 hours. I mean, that's looking something like this. That's not like, if you flick a tennis ball, yeah, all the water's gonna fly off. If I go like that, it's gonna fly off. But we're not spinning like that. We're spinning like that.
But the
It's real
water's
slow.
still going to drip off.
Why?
Why?
Yeah.
Centrifugal.
Because it's denser than
Centrifugal force.
It would still, certain things would be pulled to certain areas more than others.
Did you
And
hear what I
believe-
just?
I believe that's accurate. I believe that
But that's not what we see.
It's flat.
From what I
Sea
understand,
level.
there is an effect. This centrifugal force. It does have an effect on the effective gravity between the equator and our poles, and I believe that difference is about 0.3%. So it is there. That effect is there. The effect of centrifugal force. However, it's not severe enough to be pulling all of the water
Okay.
off like
Yeah,
that.
we just
Let me make a
disagree with
point
that.
again, Pat. let me-
Now, I haven't.
Hold on. Let me say something. You're saying
I'd like
it's
to finish my point.
you.
Why?
The
They're spinning
so
slower.
that is something that could be tested. We're looking for things that can be tested, correct? And if we go to the equator, we could take a weight that is some weight, and we could take the same scale and we could place it here of 100 grams or 100 pounds or whatever you'd like. And we could place that here, and then we could go up to the equator with the exact same weight and the exact same scale,
Yeah.
and we could measure that. I have not seen those tests, but my hypothesis would be that there would be about a 0.3% difference, that there would be other factors that could be involved. But that would be my hypothesis.
Now, will you listen to me for a minute?
Yes, I would love to.
Okay. Science says that the Earth is fatter at the equator and the landmass is fatter at the equator because of the spinning Earth. Do you
How much
understand
science?
that?
That's
Do you
how much
understand that the
science?
land
That's
is
its explanation.
swollen out of place because of the spinning?
How much?
That's what they say.
I've heard that, but I've
But not
also
the water.
heard that it's, from what I understand.
Think about it just for
that
2 minutes
could be exaggerated.
and you'll change your view.
I'm sorry, could you repeat that? 2
I
minutes?
said, think about that for just 2 minutes and you'll change your view.
Well, yes, it may be.
The land
fatter.
is moved, but the water's not.
No.
Just think about it.
So-
No more. Just end the topic.
What do you mean the land is moved? You could have
Just
float
like we're
it.
saying,
The Earth is fatter at the equator.
So how much
Okay.
fatter? That matters substantially. How much fatter? Is it 0.3%
Okay, now,
fatter?
The land is solid. Some of the
question
equator is
why
cratons.
does it matter if it's different? It's different. If it's different, that means that there is a force pushing harder in one spot, creating the oblong, or the, what do you call it, the oval.
Pear-shaped.
I was going to say pear shape.
Or pear, according to
Look better,
Tyson.
come on.
Neil deGrasse pear-shaped.
It would be, because of those forces would cause that. Now, if that was, as science says, oblate, that would mean there is a force greater here than here, causing this to push something upward. Now, what we're trying to say is anytime that there is that push or force, that's where density, mass, and all these other things come into play. And that, according to science, says water, I believe it's water, should be at the equator or at the oblate area. period, because of that force. And that's.
There's land
I would
mass.